Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In an SN2, substitution nucleophilic bimolecular reaction, the mechanism proceeds through a single concerted step with no intermediate. The transition state is the highest energy point on the reaction coordinate where bond breaking and bond forming occur simultaneously. Moving on to the next step. The nucleophile attacks the electrophilic carbon, the substrate, from the back side 180 degrees to the leaving group at the same time as the leaving group departs. Both the nucleophile and the electrophile, substrate carbon, are involved simultaneously in the transition state. Moving on to the next step. The transition state of an SN2 reaction involves both the incoming nucleophile, partially bonded, and the electrophilic carbon of the substrate, partially bonded to the leaving group, forming a pentacoordinate trigonal bipyramidal transition state. This is correct. And for the final step. Option A carbocation intermediate is characteristic of SN1 reactions, not SN2. The SN2 transition state does not resemble a free carbocation, it is a pentacoordinate species. Option B. The electrophile alone is not responsible, the nucleophile's attack is equally essential. The reaction is bimolecular precisely because both species are involved. Option C. The transition state is always higher in energy than the starting materials, it is the energy maximum on the reaction coordinate, i.e., the activation energy barrier. It cannot be lower in energy than the starting materials. Therefore, the correct answer is D. Therefore, the correct answer is option D.